Okay, so I'm Austin Tipton. I work with Anvil Ventures. We're a boutique security firm, as Jason would describe us. Today I'm going to be talking about technical reports. One of the parts of our job that doesn't get too much attention, but as you'll hear and hear, I view it as one of the more important parts of our job. So just a little bit about me. I put this slide in here to kind of encourage people a little bit, because I had a very non-standard way into InfoSec, and I kind of want to encourage people that also have non-standard paths into whatever career they have, in this case InfoSec, to keep doing it. So mine, I was actually a college dropout at first. I didn't go to college for my first year. I took a year off. And only after kind of exploring things did I get my bachelor's degree and get an InfoSec. It took a little bit of luck and a lot of hard work, and definitely a lot of luck. So keep at it if you're aspiring. It's worth it. It's even fun. So why talk about reports? Why this workshop? So if you're in information security or want to get into information security, you probably want to get vulnerabilities fixed. That's kind of the point of our field. Technical talent is important, but even technical people need to be able to communicate their findings consistently, accurately, and in a compelling manner. One of those things, one of the things that means in practical terms is writing a decent report. Well-written findings are harder to disagree with because their ideas are precisely articulated. They have references, they are objective, and they take the organization's goals into account. A well-written finding helps you work smart, not hard, by maximizing the understanding from your audience. Explaining findings well enough the first time gives you the advantage of not having to cover that ground later. The goal of the report is to create consensus, because consensus will lead to stakeholders, developers, and security teams working together to get these vulnerabilities fixed. So why reports matter. So from my perspective, I work, as I said, for the boutique firm. We're always the outside people coming in to review a product. So from my perspective, as the outside consultant, the report is my product. This is how we as consultants relate our findings and our work to our customers. From the customer's perspective, a pen test report gives them hard facts. For many development cycles, the pen test is the first security test that they really come up against that is, hard and not theoretical. Up to that point, they've probably had some sort of threat modeling done. They've probably had some sort of architecture review done, but a lot of those are very much in the realm of thought experiment. This obviously varies from company to company, and a lot of companies are getting better at involving security people continuously, but there are still a lot of companies operating on older models. And the report tends to be the only lasting record of a pen test also. So the content of the report, whether that be good or bad, will likely live on for a while. The process puts a lot of onus on the part of the pen tester to find as many vulnerabilities as we can and report these findings to the best of our abilities. So there's several components to a report. We're going to get into those here, but the bare minimum sections in a report are the executive summary, the scope, and the findings. Each of these sections have very different audiences, and they have different data that they're trying to relate to their audience. Okay, so throughout these different sections, please, if you have questions, just interrupt me and ask away, and I'll do the best of my ability to answer that question and get back on track. So I'm just gonna dive right in here. So the executive summary, overstating the importance of a quality executive summary is pretty hard. Every interested person on the project will read the executive summary because it provides a high-level overview of what happened during the assessment. The results of the report and lessons learned from the work will be here. The executive summary should have 5 different topics covered. A summary of the functionality of the application, a summary of the scope, a summary of the methodology, a summary of findings, and then your analysis of the application from what you learned and all those kinds of things. I also find that it's easiest to cover them in that order. So functionality. An easy way to start talking about an application is to describe what it does and what is new in this iteration of the application. This gives it purpose in life, essentially. So talk about features and how they work with existing features, some of the technical components, broadly describe deployment details, such as whether it's a cloud environment or a traditional stack. Generally, this is a good place to ground the conversation in realities of the application's architecture. This helps people who are not on the project day to day still have a business interest in the project. What I'm really trying to do here in this type of section is I don't want to be talking about buffer overflows when we're writing in Java. Right? I don't want to be talking about buffer overflows in the context of JavaScript or Python. So we got to kind of shove those concerns that people might have, just get rid of them so we don't have to deal with it. Scope. So after the application has been described, I like to move into what we're covering in this assignment or the scope. This should be only a summary of it. We're going to have an actual section devoted to that later, but this again is more of a grounding exercise. The details of the scope should be covered later. We're in the executive summary. We're going to cover: was there documentation provided? Was code available? What testing environments were used? What was the level of assumed breach? So that's really talking about what access is assumed. The scope and boundaries of the assessment, and covering the scope in the covering the scope in the executive summary really helps us stay on topic. Essentially, we don't want to be talking about social engineering when this was a white box pen test. Those are 2 totally different things. One's a red team activity and one's software. So methodology naturally sort of flows out of that now that we have established what we have and what we're testing. The basic question that this part of the executive summary is answering is, how did you attack the application? Like, how did you take the tools at your disposal and accomplish the goals? For example, let's say that the assignment's target is a web application and we have the code as well as a testing environment. I would write something to the effect of saying that I started with endpoints that every user can use, mapped those endpoints to code, performed a code review, and if anything in that code review was worth investigating, I then tested it with dynamic testing. A statement like this tells the reader how you use the resources that were provided. Besides being more professional and a good description of how you went about your assessment, this helps the customer understand from what perspective and level of information the application was tested. For example, if you had code but didn't use it much, the test is closer to a black box test than even though you had code. So this is really to give people a window into your thought process and a window into what things have been levied against the application. So summarizing the findings, if there we want to talk about notable findings here in broad strokes. We don't want to go into a whole bunch of detail. That's later in the findings section. We want to highlight findings that are especially impactful, and that should be fixed immediately. So if you got your root shell here, you want to write a little line in there about that. It's gonna excite people, for example, especially the non-technical people. And to an extent, that's good. We don't want to peddle in fear and doubt. But if you did it, it's not. It's now grounded. That is a reality of the application. We want to bring attention to important trends, such as a habitual neglect of input validation or a lack of attention to important configurations. Anything that is systemic rather than a one-off. In this case, systemic can mean a lack of process around development or something more technical about code. It's, from our perspective, it's sometimes hard to talk about processes, like business processes when it comes to development, but you can see the symptoms of poor processes in code. That's why processes exist, is to improve code quality. And if code is bad quality in specific ways, you can talk about that. And really, it's your responsibility to talk about that. Conclusions. So conclusions from the security engineer's perspective can be very valuable to people who are not always involved in security. Simply talking about broad categories of vulnerabilities and how they relate to each other can help people see trends that would otherwise would not be apparent. Security people have a unique view. Like, we don't do the same thing that a developer does day in and day out, so our view is very different. This is also where you should share recommendations for the application. So if you think that the application's launch should be delayed, mention that. That's important. Make sure you give a professional assessment of the risks that you discovered. Give the customer thoughtful, professional, but sometimes harsh feedback is exactly why we are hired to do this work. So I guess in more practical terms, that means you don't want to come in and just say, oh, everything's terrible and whatever, and kind of not give any sort of feedback about how that's fixed or what that really means in terms of practice. You want to say that in more words, essentially, in terms of, we were able to do these things, we were able to get code execution, or we were able to get that SQL injection or no SQL injection, or whatever that high or critical finding is. We want to stop them from saying everything is fine and let's just launch and make money. That's not what we want them to do. But we also want to not insult them because they're just going to disregard you. We want to have a happy medium between, I see you guys tried, we have some problems over here, let's come together and fix these things, because at the end of the day, that's the goal, right? Is get things fixed. Okay, so now that we're done talking about executive summaries, any questions about any of what I just said? Okay, on to scopes. So this is where we really reiterate the legal boundaries of the assessment. And this is supposed to do a couple of things. It helps, again, ground the conversation more, which we already did in the executive summary, but this is much more detailed. This is where we list the exact code packages that we had access to, if any, what testing environments we had. We want to say what binaries, like down to the version of what we had. If we're talking about a code repository access that can get, will include like the pull request number or the tag or something like that, so that no one is going over there to whatever resource we supposedly had and saying, well, why didn't you find XYZ? It's like, well, are you looking at the right version? We want to be very precise about this. Things like IP addresses and host names are very important to this, especially when on network level type pen tests, because some things will be explicitly out of scope. Some of those things will be in production versus a testing environment. And we do not want to cross that boundary between testing and production. It's very poor practice. And we could cost the customer money, which is not the goal. They're already paying us a lot of money. We don't want to have to cost some additional lost revenues. Here we want to reiterate the exact level of assumed breach and what that means from a technical perspective. So that means, what accounts did you start with? What presumed access to those accounts? What are our assumptions about the access that those accounts have? And then that will inform findings later on. So for example, if we have a user that is supposed to just be able to edit their own stuff, we want to mention that in the scope so that when we reference that user later in our test findings, we have some idea that what we're talking about is actually a vulnerability from the reader's perspective. Okay, so the findings section is obviously where the findings go, but this is where we start really getting technical. This is where we want to be, we go into excruciating detail about why this finding is in here, and all the different components of that. And we're going to dive into what that really means here in a second. But this is where we need to bring our technical knowledge to bear. So a finding is a security vulnerability or violation of best practice. We define it that way because we're looking for defense in depth. We always encourage clients to get away from the idea of that really strong exterior and that gooey inside. That's garbage. So we always focus on defense in depth. So we will call out things that are not necessarily exploitable now, but given a problem in the future, will be exploitable. That matters, and customers should care about that. Those will have obviously lesser impacts and lesser severities, but they will be mentioned in the report. So every finding needs to cover 7 essential pieces. It needs to have a title. We need to talk about how likely whatever it is we're talking about, how likely that is to happen. If it happens, how impactful is that? How and the overall severity of that. We need to talk about the technical details that led us to this particular conclusion. We need to talk about how to fix it, and we need to back up what we say with outside resources if possible. So first thing is a title. We need these titles to be short. We need them to be descriptive. We need them to, not use unnecessary buzzwords, but sometimes a buzzword's nice. So for example, we could say, if we're talking about an XSS vulnerability, we could say improper encoding in front-end component, and that would be accurate. However, this title is more or less a missed opportunity. Saying something like cross-site scripting would get people's attention. And we kind of want to do that to a degree. We want to draw attention to these problems. And you better believe it, the developer on the call that wrote that code and you name that component and you're saying there's cross-site scripting in it, that guy's paying attention. And you want that person to pay attention because you want them to learn from their mistake. But at the same time, this is designed to be a learning experience also. So impact. When we're talking about impact, this is how bad is it? What happens if this actually gets exploited? And this question or this section is really trying to answer the why do I care kind of question from the customer's perspective. Like if, for example, one that I like to bring up is data security within the company, say like Twitter. Like a lot of people, like when I interview people, I have a scenario where I talk about data security from the context of Twitter. And I say, well, so what that you can, playing devil's advocate, I say, so what that you can perform a SQL injection. All this data is public anyway. And that the goal is to force people to look at what data really means to a company or to an organization and really assess that, because obviously the answer there is, well, the value of the company comes back to the integrity of that data, not that whether it can be read or not. That's kind of the point to a large degree. But it does, like, integrity matters is basically what it's getting at, and a SQL injection would, compromise integrity. So when we're talking about the impacts, we want to talk about things like, does this impact a primary business case? What is what is compromised, whether that be confidentiality, integrity, or availability, or maybe some combination of those three? How will our users react if this is exploited? Would they think less of the organization? Would the organization care about that? Does this significantly hurt the business? Is really the kind of question we're getting at. And if the answer to that is yes, we want to reflect that in our finding, in our rating. So likelihood. Likelihood acts as a counterbalance to impact. Some things are extremely impactful, but not very likely. Maybe that component sits really far back in the system, or whatever the case may be. But there are always risks that are very impactful, but not all of those are likely to come about. The likelihood rating attempts to quantify the risk in terms of what needs to take place in order to exploit the vulnerability. So likelihood should consider a few things, such as what level of access do I need in order to exploit this vulnerability? Is physical access needed? And if so, is physical access hard to get? How many people have access? What technical difficulty is the exploit? Like, is this a really hard thing to do, or is it trivial? Does it cost a lot in terms of money or computation? Are there other things that need to be compromised before this particular vulnerability can be exploited? Lots of things can factor into that. Likelihood can be very subjective, but most people familiar with the system should generally agree on the applied rating. This gets difficult because of that subjectivity, but we can generally quantify likelihood and impact, for that matter, into a high, medium, low kind of rating. And also, because of that subjectivity, we really want to rely very heavily on our rationale for the likelihood. We want to write about why we think the likelihood is what we say it is, taking into account all those things we just talked about in terms of how hard it is to get to the exploitation of the vulnerability. So severity. This sort of graph or chart is the simplest way to communicate severity. Personally, it's my favorite because of its simplicity. At the core of all rating systems, severity is comprised of a combination of impact and likelihood. CVSS does this in its own way by asking a bunch of questions around the vulnerability and where it sits in the system, difficulty, tools that exist, et cetera. From the reader's perspective, severity should not be a surprise after reading the impact and likelihood sections of the finding. It should be more or less a given. You should definitely lead your reader to that conclusion. So a quick note about rating systems. From what I've seen in the industry, there are two systems that are primarily used for ratings. At my previous company, we use this high, medium, low kind of system. We use a high, medium, low system. Some specific customers will either have some proprietary thing based on CVSS, or they just use CVSS. Personally, I kind of think CVSS is a little heavy-handed and is very it kind of cuts out some, can cut out some context out of the situation where we should just, where the high, medium, low kind of system, it allows you to take into account your system. A lot of, there's not, it's really hard to come up with a severity ranking system for all types of architectures, all types of applications, and all those kinds of things. So the high, medium, low kind of system gives you that flexibility to use human judgment and come to a meaningful rating. So technical details. The goal of the technical details section is to guide an engineer through your process well enough that they can recreate or uncover the vulnerability independently. When considering your audience, keep developers in mind. There will be times when your audience is other security people, but that is the exception rather than the rule. This should be done with some combination of written words, screenshots, code snippets, and the like. So an easy template for writing this section is you start with some words about where the component sits in the system and what it is supposed to do. Second, you want to discuss how the vulnerability was discovered, mentioning what techniques or tools were used. This can help the other engineers on the customer side understand where you're coming from and what you're seeing. Third, discuss what the vulnerability actually is. Talk about what the core issues are, down to the fundamentals, like really down to the fundamentals of what the issue is, because that's going to come back into the mitigation section later on. And if you neglect the mitigation, or sorry, if you neglect the fundamentals in the details section, your mitigation has a large risk of making no sense to somebody who is not familiar with whatever type of vulnerability you're trying to discuss. Finally, you want to talk about how to exploit the vulnerability. Proof of concept is wonderful. A lot of times with vulnerabilities, a proof of concept is very short, and you can just, copy paste that into your report, and it just sits there. And if there's a visual component to it, maybe you're doing the standard alert one kind of thing in XSS, put a screenshot of that in there. All these things there will remove doubt and make your finding very concrete. So the mitigation is pretty simple in concept. It's just how do you fix the thing, right? How do you fix the problem? Sometimes the mitigation is as simple as telling a customer to enable some configuration, but many times it's much more complicated than that. You want to spend time explaining how to fix the issue, because again, that's the point of all this, right? Do not leave things to interpretation. You want to be very detailed in this section. You want to discuss whether the mitigation simply reduces the likelihood of exploitation. You want to talk about if it actually mitigates it 100%. So perhaps the vulnerability is a logic flaw. Changing that logic should really remove that flaw. There's other situations where there's other things at play, like maybe you have dependencies from other systems that require an outdated system. For a while, a lot of companies were using NTLM past all recommendations, simply because there's too many things that relied on it. So they couldn't move away from it for quite some time. So try to dive into those types of nuances with the customer. This does take a lot of effort. A lot of times this will require you to essentially interview people on the developer's side or other stakeholders, because you need to have additional context into what it means for them. So in the case of, say, NTLM, the answer is, like, from a very naive perspective, it's like, well, I was able to break NTLM hashes. Well, don't use those. Well, every component in my company uses those. So now I have to migrate some large n number of systems to that. Well, maybe we should go into more nuance about what that really means. Now, references. This, especially with newer customer relationships, is really important. Or going into something of which you're even maybe necessarily new to. But you want to back up your claims with outside resources. This makes your claims more valid. It's just like a research paper in a lot of ways. This is. You're researching a very specific product and how it can be exploited. I really like OWASP. Everyone likes OWASP. And because everyone likes OWASP, I really like to lean on them because no one's going to argue with OWASP. I can just take their URL, put it for the applicable article, put it in my references section, and use that in my details section to point them in the right direction. And a lot of times these places are going to say things a lot better than you will and me. So use that. It's free and open for a reason. When a particular technology such as a language or framework is involved, use that technology's documentation. So all the web frameworks out there that you'll run into will have a security section, right? They're going to have a web page that says, this is what we know not to do. This is how you can really screw yourself if you use these particular development patterns. Those are really handy to look at from the pen tester's perspective, especially if you're not 100% sure about this particular framework, but also it gives more credence to what you're saying. The other place I really like to look for very specific things and are universities. Universities have some really specific, wonderful research, especially around topics like cryptography, that normally wouldn't get released by other for-profit institutions. Government websites are also good for that. So this was designed as a workshop, so that's why it says hands-on practice out here, but we talked about that and we decided just to do the talk portion of this. So I'm just going to do questions instead. So I'm just going to open it up here, and whatever you have questions about, whether you're about this or more general pen testing stuff or more customer relations kind of things, or whatever you have questions about, feel free to ask. We have plenty time.
So this is Andres. Are you able to hear me?
Yeah, I can hear you. Kind of faint, but sure.
Okay. One of the questions I have is the technical report generally the final product, or are there times where the customer also expects you to provide like a presentation to the stakeholders where you, speak about your findings?
So when I was writing this, I had a hard time keeping it about just the writing portion, because normally we use the report as a presentation a lot of times. So it's both. We go through the report with developers, with stakeholders and project management at the same time at the end of the engagement, so that everybody's on the same page. Everybody can ask us whatever question, from the most technical thing all the way up to a higher level business impact kind of thing. So we're really covering the gambit here. There's another reason why these different sections have different audiences, and we're trying to talk about different pieces of data, because we're talking to a wider range of folks.
Okay. Thank you.
Yep.
So I'll ask another. So
Sure.
I've been on the receiving end of these reports as a customer. And one of the things that we've experienced in a recent one was there's a vulnerability identified in a third party product. So it wasn't something that we developed in house. So in general, how I guess what do customers expect from you in remediating those? Do they just want you to communicate the findings to them and then they work with the third party, or do some clients expect you to then reach out to the third party and I guess
So
work
that's
towards?
that really depends on, in a lot of ways, the maturity of the customer. Um, People who develop a lot of solutions for themselves, whether those be purchasing components or developing from the ground up, they more or less say, "Hey, thanks. We'll get back to the vendor about this, and they'll fix it." Some other companies are not so good at that, and they don't really understand what that really means to report a vulnerability to a vendor. And we have to be more handholdy about it, which is, it's fine. We're very happy to do that, because from I guess a community service standpoint, a lot of these vendors, their goal is to sell to a whole bunch of people. So this software is living in a bunch of different environments, which means this vulnerability exists in a whole bunch of different environments, which we should tell them about that so that people are more secure. So we really take the customer's maturity and comfort level into consideration there, and try to work with them to come to a solution where we do disclose the vulnerability and keep them secure and safe because they have a bunch of different legal concerns as well, and that's kind of where it gets hazy and not as straightforward as we would like. But we do our best to work with them, essentially, is the answer, and that means a whole bunch of different things depending on how they react to the news.
Okay, thank you.
Any other questions?
And if you don't have report questions, I'm sure he would be happy to answer other things related to pen testing or getting into pen testing.
I have a question.
Go for it.
So what are some non-traditional ways of kind of breaking into pen testing?
So that's an interesting question, depending on what decade we're in. For a bit, the traditional way was to not go through college and kind of just learn on the internet. Now the more traditional way is kind of becoming go through college and do the track. So I guess I have friends who have done it both ways. I kind of did a hybrid of either one because the school I went through didn't really have a security program. So to a large degree, I'm self-taught, but I have a computer science background. A lot of people I know, they started modding games. They started just trying to get free stuff. It really just depends on what your interests were and how creative they were about trying to figure it out. More people now that I know getting into it are very much more academically driven through it. And there's just so many tools nowadays that, and there's so many like paths that people are open to that there's just so many ways to get in now. Like one of the guys we hired didn't finish school right away. He actually put it on pause and came to work for us. We suggested that he finish school, but he's like, nah, I'm fine. Because he was pretty good at doing hack-the-box stuff, and he passed our interview really well. So he said, well, I can make money, so I'm going to do that. So it was really just, it's find your own path, man.
Yeah. Thank you.
Yep.
Any other questions?
Yeah, so I have a question. So one of the one of the topics that I'm interested in is code review.
Mhm.
And I don't have a development background, so I think sometimes I have a difficult time, or at least in the confidence level. Like I can identify things like, oh, that's not unsanitized input. Uh, but then when it comes to, oh, you want me to then write code to tell you how to fix that, that's a little trickier. So do you know of any resources that one could use to, I guess, become better at code review, and maybe development for a security professional? Like I don't want to become a Java developer, but I would like to be able to, find vulnerabilities in Java and then have an idea of how to fix them.
Yeah, so this is a section of our industry when it comes to like those free and open sources that are a little lacking when it comes to hands-on practice kind of stuff. I think it's because it's hard to automate this. There's not a fixed answer necessarily. So when it comes to getting better at code review, I always advise people to learn the fundamentals. And what that means in this particular case, when it comes down to code, is knowing your way around procedural and functional programming. That's gonna nail down a lot of the problems for you right away. Being able to understand recursion really well is going to help. Like for example, like if we have a Java shop, there's going to be a mix of Java, a procedural language primarily, but because they're running Java, there's going to be a bunch of people that say, hey, I can run Scala. And that can work like very differently. It requires a different thought process of how to do that. So once you're good at understanding the difference between procedural and functional programming, then apply that to the language you have there in front of you. You want to lean on the technical documentation of that language. A lot of the vulnerabilities you're going to be finding are going to be the same, whether they be in Java, Python, Dr. Racket, or whatever other one-off language there is. It comes down to being able to speak to what the fundamental problem of that is, and then coming back to the developer with that fundamental question and relying on their code experience to fix that. You're the security expert, not the language expert, if that makes sense. A lot of those two things tend to overlap at times, and that's why we have documentation, and that's wonderful. But we need to be good about the fundamentals of the vulnerability. So if it is an input validation issue, we need to say that we have an unacceptably large range of characters that are accepted, and this leads to data that shouldn't be in the system into the system. Or in a more extreme case, we have these characters that are being allowed past the perimeter, which allows us to inject into this other syscall over here. So we're able to use one pretty low kind of finding to leverage a different violation of best practice. So bringing it back down to the fundamentals allows you to work into a lot of different languages that you may not have written a line of code in. I have written 0 lines of Scala, but I can still do a Scala code review.
Okay, cool. Thank you.
Anyone else? Well, if no one else has anything, we'll wrap it up for the night. Thanks again, Austin. Awesome presentation.
Thank you.
Thank you.